What factors make a typhoon into a super typhoon? Can India also get super typhoons like Ragasa? And how come Philippines falls in the path and is permanently vulnerable to such typhoons? A monster storm is racing across the Pacific. It has already battered Philippines and Hong Kong is threatened as we speak. But the question here is how it is different from a normal typhoon. What is a super typhoon and why Philippines falls in the way of such super typhoons? And can India be also hit by some, and should India be prepared for it? Hello everyone, welcome to Vajram and Ravi's Flash News. My name is Shubhangi Singh and today we are going to understand the phenomena of super typhoon in very clear detail. So let us start with understanding what exactly is a super typhoon. Super typhoon is nothing but a very powerful tropical cyclone which is occurring in the Northwest Pacific region. Why are we calling it a super typhoon? First of all, the term typhoon is used for tropical cyclones which occur basically in the Western Pacific region, and they are nothing but a class of tropical cyclone itself. Now, the reason they are defined in a different segment by the name of super typhoon is because of the intensity. So, it is not a new phenomena, it is just the same phenomena of tropical cyclones but with a new intensity here. So if we go by the definition of JTWC, that is US Joint Typhoon Warning Center, it basically says if in a minute sustained winds are of more speed than 240 km per hour, that means it is a situation of a super typhoon. Similarly, the same phenomena, if defined by a different agency, PAGASA, that is Philippines, the agency from Philippines, it is said if the winds are higher than 185 km per hour, then it is a super typhoon. Now, basically the intensity, the variability of intensity and the labeling by different agencies can change, but in simpler words, you have to understand it is one of the strongest versions of typhoons or tropical cyclones that exist. So basically when we are talking about a tropical cyclone, it is a situation in which we get to see a low pressure system where there is a proper convection which is organized and there are intense winds combined with extreme and heavy rain. So at this moment, let us briefly decode also the formation of tropical cyclones and typhoons and how does it exactly take place. So when we are talking about tropical storms, tropical cyclones, the basic requirement that where it is initiated is a warm sea surface. So the temperature that is to be seen at the sea surface has to be over 26 degrees Celsius and it has to be region of high humidity as well. So the first condition here is warm ocean water which is present, and because of that the air starts to rise, this moist air starts to rise. Now this is the visual representation where you are seeing that moist air is gradually rising, and after a point of altitude the condensation starts taking place which also releases the latent heat. Now this condensation is responsible for formation of clouds as soon as the condensation takes place. Now the next stage comes in where we get to see a low pressure area is created because of the rise of the moist air, and this column of low pressure is the reason that you will find that winds coming to this particular center, because we know the movement is from high pressure region to low pressure region, and that is why a column is gradually formed. So you will find formation of clouds, you will find a low pressure center which exists, and the exit that takes place as the pressure in the center column is weak or low, you will find that because of the movement, the speed of the wind around it increases. If I have to visually put it, You can see it something like this. So the warm moist air is drawn into the center and the wind that goes out, it is spiraled outwards. The center column, which is also the eye of the cyclone, it is calm and clear and there is a clear sky above it. However, if you find apart from the eye, you will find that the winds get stronger towards the eye wall and there is formation of clouds. Now this movement of wind takes place because of the Coriolis force. Now Coriolis force acts differently in the northern hemisphere and differently in the southern hemisphere. Can you tell me in the comment section what is the movement of Coriolis force? What movement it creates in northern hemisphere and how it is different in southern hemisphere. Now this will also make you understand that if the warm water is present, the consistency of warm water is there and also the wind shear. That means if vertical winds are going like this, then if we are talking about winds in horizontal direction, the wind shear is low. In this scenario, this keeps on intensifying and this rotation that we are seeing will go on until there is some sort of dissipation. That means warm water source is not present anymore or it makes a proper landfall. So in this scenario, we get to see that how warm moist air, low pressure and gradual incidences can lead to the strengthening of the storm, which will be gradually classified as a tropical cyclone or typhoon based on the intensity of the wind itself. So if we have to summarize it, warm water, moist air and then we have cyclonic rotation because of Coriolis force combined with low wind shear is what leads to the generation of tropical cyclone, where eye is the calmest and eye wall, this region has the maximum activity that is seen. And after a point of time when the intensity goes beyond a marked point, be it 240 kilometers per hour as per JWTC or as per Pagasa it is 185 kilometers per hour, that is when this whole phenomena, which is just a tropical cyclone, turns into a super typhoon or just a typhoon which turns into a super typhoon. Now that you have understood what exactly is a super typhoon, let us distinguish between normal typhoon and a super typhoon. As I said, the difference exists only in terms of intensity. So if you are talking about the wind speed, you will find that in typhoon it is less than 118 km per hour. But when we are talking about super typhoon, based on agencies, but you have to understand it is almost above 185 km per hour. If you talk about rainfall and surge that is seen, in typhoons you will find heavy rainfalls. They might be damaging in certain scenarios also, but they are catastrophic in terms of super typhoons. They are extreme flood scenarios which are seen, and there is sometimes 5 to 10 meters of storm surge which is also present. In terms of destruction, because super typhoon has more intensity, it is a possibility that it might flatten buildings, devastate coasts and etc. And if we talk about frequency, the frequency is definitely very different, where we get to see typhoons several per year. Super typhoons are comparatively a rarer phenomena as compared to typhoons because of the limited frequency in which they occur. When we talk about the differentiation again, as I said, the main differentiation is based on intensity. So if we are looking at super typhoons, then we see that in terms of especially Saffir-Simpson scale, they are put up in category 4 and 5. So when we are talking about Saffir-Simpson, they basically show us the wind intensity, especially in hurricanes. Now, based on this scale, super typhoon is a situation where we get to see extreme damage or catastrophic damage because of the wind intensity, and wind intensity is above almost 200 km per hour which is seen. So this must have brought absolute clarity to the fact that super typhoons are absolutely destructive, catastrophic, and such a situation is difficult to manage, and this calls for a clear understanding in terms of disaster management, geographical location, where the frequency is, etc. So now let us move to understand can this particular phenomena exist in particular places, or it can come down to India as well. So before that, let us address the situation that why it is being seen in Philippines so much. So if we talk about the frequency of typhoons, you will understand that Philippines get to see 25 typhoons, on an average of 25 typhoons per year, and this will give you more clarity. If we look at the Saffir-Simpson hurricane wind scale, which we had just understood, in the terms of the frequency at the world map, you will find that the highest intensity and the highest wind scale, it is found in this particular region of Pacific Ocean. And you will be able to see that Philippines lies right here. Now let us understand that why Philippines is a hotspot for typhoons as well as super typhoons. Why does it fall in the way of such typhoons? So the first reason here is the geographical location itself. So as we just talked about formation of tropical cyclones and typhoons, we talked about warm water. We talked about a few conditions, right? Warm water, moist air, low wind shear. The problem is this geographical location has a combination of all of these. Let us understand how. If you talk about the geographical location, first of all, it lies in the northwest Pacific typhoon belt where the frequency is high. Why it is high? Because of the warm sea surface. If you see the average temperature, the isotherm here, you will let me know in the comment section. I'll also explain it here because otherwise it wouldn't make sense. So when we are talking about a line which is showing equivalent temperature, then this line which is close to Philippines shows that the temperature here is on an average 28 degrees Celsius. So this shows this region has warm seas and the ocean surface temperature is more than 27 degrees Celsius, which directly feeds the such tropical storms. Second thing that we get to see here itself, that there is a huge open Pacific patch which is present, which further allows a long stretch of warm water which facilitates the intensification. So if the storm is moving in any direction, the feeding source, that is the warm water, which will be present. Second, low vertical wind shears. So when we are talking about vertical winds existing, the wind shear which can break them down is extremely low in this particular area. Another thing that makes it a hotspot is the archipelago which is present there, basically 7,000 plus islands and long coastline. That means there are multiple landfalls places which it can take, and there is no big patch of land which is present where the dissipation of this whole storm can take place. And to further fuel the fire, we have climate change. With climate change, ocean heat content is increasing at a never seen rate, and it is also allowing faster strengthening of such storms. So it is the combination of the climatic situations, geographical location, that Philippines falls in the movement of such typhoons. And this is not the first time. Just in 2020 itself, we saw the world's strongest landfall, that is Goni typhoon, was seen in this very region. We saw Haya in 2013 where there were more than 6,000 deaths, and this is something that shows that what such destructive storms can end up doing. Now moving to our question, that can this happen in India? The reason a super typhoon cannot happen in India are two. First, it is terminology based. We do not use the term typhoon, we use the term tropical cyclones, and based on IMD classification, you will find that a super cyclonic storm, when the wind speed is more than 222 km per hour, it is considered as a super cyclonic storm. Even when we are talking about situation like super cyclonic storms, these occurrences in India are very rare because of certain geographical as well as again climatic factors which we will be getting into. But still we have seen some destructive super cyclonic storms such as Amphan, if we talk about 2022, back in 1999, Odisha has been taking the main hit in terms of super cyclonic storms or the cyclonic storms in general. Can you tell me the reason why? Now let us move and understand that why it is a rare occurrence in India and it is a limited possibility that we will see super cyclonic storms, and they are much more rare as compared to the Pacific Ocean. So the first reason which facilitated super typhoons in Pacific is the limiting factor which becomes for us is the limited space. We have smaller water bodies as compared to the large stretch of Pacific. Be it Bay of Bengal, be it Arabian Sea, that means there is limited base which is available for the cyclonic storm to be fueled by the warm water itself. Second thing we get to see that there is a possibility of early landfall because there are multiple places such as Andaman, Myanmar. That means as soon as the landing, that means the source is cut off, dissipation takes place, that means the reduction of maximum strength has happened. Then we also get to say there is a lot of wind shear which is present in and around India. That is the disruption to the cyclone core occurs because of the wind shear that is present. And the most important factor is the presence of monsoon influence. Now when we are talking about monsoon influence, that means seasonal winds movement varies. The wind movement changes in every season and that hinders any sort of intensification if we are talking about be it in the region of Bay of Bengal or Arabian Sea itself. Even after that, India is not immune to cyclonic storms. We have seen intense cyclonic storms, but we have been saved from super cyclonic storms because of the given limited factors that we have just discussed. But we still get to see many storms, and there has been a change of phenomena that we have seen in recent times, that Arabian Sea is seeing more strong storms in recent years, where we have seen in last 4 to 5 years multiple storms such as Taukte, Biparjoy. They have been seen from the end of Arabian Sea. Can you also tell me in the comment section why this change has happened recently, where earlier Bay of Bengal used to be the concentrated region of cyclonic storms, now it is Arabian Sea. Now this whole understanding also calls for an insight into disaster management, that what needs to be done and what lessons need to be learned from this super typhoon so that we are prepared for such natural and man-made disasters which lie in front of us. So the first important part lies here is definitely focusing on forecasting through advanced technology using satellite, Doppler radars, AI models, and then protecting. That means putting in money in the coastal infrastructure, shelters, and after that comes the planning part, be it the land use planning, surge prone areas, community awareness, regional cooperation, so that if ever such a time comes across our nation, we are better prepared for that. What are your thoughts about it? Let me know in the comment section. That was all from my side. Thank you.